Students, this is going to be your lesson on how to graph a tangent function. So we have the same learning goal as last time, which is basically going to be, instead of just the vertical asymptotes, though, in the domain and range, we're going to actually graph the entire tangent function. So we're just going to go through a couple of examples. As a reminder, we have the a value and then tangent and b, x minus the h, and plus k. Also remembering that PB is equal to pi for the tangent function. So right here we have the B value as 1/4, so P times 1/4 is equal to pi, which means the period must be 4 pi. So I'm pretty stretched out. This H is going to move us to the right, shift right pi. And this 3 is going to actually have us reach infinity and negative infinity faster. It's not an amplitude, but it is going to increase the speed with which we reach both vertically the infinity and negative infinity. Okay, so let's take a look at how we're going to graph this. So we have all these parameter changes. We definitely want the anchor point to start here at pi. There's no vertical shift, so I can actually start right here, and that's fine. And let me go ahead and just label this as pi, and then we'll say 2 and negative pi. Okay, I think that'll be good. All right, so now we need our vertical asymptotes. So knowing that knowing that the period is 4 pi means we're going to go 2 pi to the right and 2 pi to the left. So here is an asymptote, and here is another asymptote. And now our job is to go ahead and find a couple of special points that we're able to plot. I see this 3, and I'm going to make sure I go up 3 and down 3. And let's see what happens here when I look at the middle between the anchor point and the asymptote. This is our middle, right? So that's 2 pi. So let's see what happens when we substitute 2 pi. We have 3 times the tangent of 1/4 times 2 pi. Oopsies. I'm having a hard time today. 2 pi minus pi. All right, f of 2 pi is 3 times the tangent. This gives me 1 pi times 1/4 is pi over 4. Now we know tangent of 1/4 pi is just 1. So f of 2 pi is going to be 3. So notice from this spot here that we're looking at, in between the one vertical asymptote and the anchor point, we're going to go ahead and make a point up at 3. We're going to do the same thing in the middle now between the left vertical asymptote and the anchor point. We're going to do the same thing and go down to -3. So I'm going to just do this in a highlighter so you can see what's going on. Actually, let's get that vertical asymptote a little taller. Kind of running out of space here. Okay, so we're going to go from here up and from here down. Oh, I don't love the way that one looks. Oh, that looks worse. I'm blaming the highlighter. So this is going to be really stretched out. What I would definitely suggest, type this into Desmos. Whenever you're practicing, type it into Desmos and check and make sure that you're getting that same picture. Okay, let's take a look at this next one. Now, with this one, what I did is I put in this negative because that's going to reflect across the x-axis. That's going to make things a little bit weird. And this is our b value. So again, PB is equal to pi because it's a tangent function. The period times 2 equals pi. And this means the period is just a 1/2 pi. So it's going to be kind of squeezed a little skinny there. This is a vertical shift. So we're going up 1. And this is reflected. And we're going to reflect it across the x-axis. All right, let's see what we can do with this one. All right, so we're going to really want to spread this out. So I guess I'm going to do this. I'm going to do pi about this wide here, 2 pi and negative pi. And we'll add more if we need to. This will be 1, negative 1. Okay. So the first thing we want to notice is that we do not have a horizontal shift. So that anchor point is going to actually stay right on the axis here, on the y-axis. However, we are going up 1. So my anchor point is really going to be right there. Okay. Now, the entire period is pi over 2. So let's add some more parts here. We have, this will be 1/2 pi. So this is a 4th pi. That's negative pi over 2, and this is negative pi over 4. So for our vertical asymptotes, we're going to need to go to the right of 4th pi and the left of 4th pi. It's going to be very skinny. Okay. And since this whole thing is going to be repeating and I didn't repeat the last one because I kind of ran out of space, but in this case, we're going to have each new period is 1/2 of a pi. So we can see that we can actually write several of these. Now let's think about more points that we can plot. Let's think about what is in between 0 and pi over 4. It would be 1/2 of a 4th, which is an 1/8. Let's see what happens here. G of an 1/8 of pi equals the opposite of tangent times, or of 2 times pi over 8 plus 1. So G of an 1/8 pi is the opposite of tangent. Now 2 times an 1/8 is a 4th. So if you were getting a little anxious with the fractions, this is actually now a very nice fraction. This is 1, which is negative 1 here, plus 1. G of pi over 8 is 0. So look what happens here. I'm going to actually move down. And for this other, for negative 1/8, I'm going to move up. And this is hopefully what you're seeing with that reflection, is that I'm going up so as I, go to the left asymptote, I'm reaching to infinity. And then as I go to the right, I'm reaching negative infinity. And we can repeat this. Again, I'm looking in between my anchor and my right asymptote, and I'm going to go down 1. Between my anchor and my left asymptote, I'm going to go up 1. And so we're able to reproduce that, and we have those cycles. All right, I'm going to give you one more. If you feel okay from here, that's fine. You can stop the video. If you'd like one more, we'll do one more here. Let me find. All right, I'm just going to work on this page. So m of x equals 2 tangent of 1/3. Just going to have a little more going on and a little messier fractions. And let's see what we can do here. Now, again, if you want to try this, just pause it, try it. You can always check it on Desmos or check it with me, obviously. So for this one, I'm going to start with my PB equals pi, and I know the B value is 1/3, which means the period is 3 pi. Okay, 3 pi. This also is going to go to the right, 3/4 pi, and down 1. All right, we got a lot going on in this one. Let's see. Let me change colors here to try to separate this a little bit. And let's try that to start. Okay, so I think I'm going to go, we need 3 pi, don't we? I'm going to change my mind a little bit. Let me see if I can make a little better space here. Okay. I think I'm going to do my axes here, and then I'm going to go 1, 2, 3 pi, 4 pi, and I'll go to the left 1 pi. All right, we'll see how we can do with this, and we might have to extend things. That's totally fine. All right, so the anchor point, we think about it 0, 0. We're going to move it to the right 3/4. So I'm going to make some tick marks in here so we can see that these are now in fourths, and we're going to go down 1. That's going to be my point. Okay, now from here we need to find the asymptote. So we need to go from the left and right of 3/4. So again, this is 3/4 pi. We want to go to the left and right 1.5, which is going to make us, if we're adding 1.5 to that, so that's 2.25. So let's go ahead and put in those little breaks. So 2.25 is right there. And then I'm going to go 1.5 pi to the left of 3/4 pi. So 1.5 will be, let me get the little tick marks in here again, is going to actually be at -3/4. And so the total distance is going to be 3 pi, okay, for that one cycle. Now, we need to find out where is the middle here so that I can plot some more points. So we're at 3/4 and 2.25, which is going to be right in here, is going to be that middle spot, okay, which is 1.5 pi. So 1.5 pi, if we plug that in, we're actually going to move up 2 spots because we have this 2 right here. So let me go ahead with the pink and get some more values in here. So from this, in between the anchor and the vertical asymptote is 1.5. So this is 3/2 pi. And I'm going to go from the anchor, I'm going to go up 2 spots and make a point. So I'm going up to the 1 actually, because I'm down here at -1. So I go up vertically 2, and then I'm going to go and do the same thing over here. Where's the middle of this? It's right here on the y-axis. So from here, I'm going to go down 2. Oops. And this is going to go obviously off my page here, but that will be, the left part will be going down towards that vertical asymptote. Definitely check your work on Desmos. It'll make it easier for you to see what you're doing. Make sure you use that little tool so that you can adjust your x-axis to whichever increment works the best for you. But you can make up all sorts of problems.